Welcome, this is the Fixed Code Protocol implementation demo. The complete system consists of three main components. A PC running Hyperterminal, this is where the received messages are displayed. A receiver, which consists of an SOH SH8 microcontroller and a Freescale RF transceiver. Finally, the transmitter key fob, which sends the message frames. Two different transmitter implementations are available. One uses an ultra-low power 8-bit microcontroller, the QE8. The other uses an extremely cost-effective MCU, the KA1. The implemented communication protocol uses a unique fixed code to identify each key fob. The transmitted frame is composed of four sections. The pilot period, indicating the beginning of a frame. An address code period. This is the ID that identifies the transmitter. The data code period, that contains the message or button pressed. Lastly, the anti-code period, consisting of 4 defined bits indicating the end of a frame. The fixed code solution is ideal for very cost-effective applications as garage door openers, small home appliances as fans, automated windows, and security systems as wireless sensors. Freescale also offers a variable key communication protocol that provides cryptographic authentication of key fobs, named BKSP, Variable Key Security Protocol. For more information regarding Freescale BKSP solution, please refer to the web link freescale.com/BKSP. In this demo, the fixed code solution will be presented.
Right here we have the MC33696 PLL tuned UHF transceiver. This is plugged into the MCU port of the Demo 9 SO8 SH8 demo board. The whole system is our receiver. We also have the transmitter, which is the VKSP key fob. This contains an ultra-low power 9SO8 QE8 MCU.
The transmitter hardware was originally developed for the BKSP, a higher-end remote keyless entry solution from Freescale. For more details, please visit Freescale website. The low-cost 8K8 transmitter hardware is shown in this slide. Emphasis was made in minimum component count while designing the transmitter. More information can be found at Freescale's website. The ultra-low power QE8 transmitter features are listed in this slide. Besides an excellent power consumption in run and stop modes, the Freescale silicon and software implementation are a perfect fit for garage door openers and security systems, among other remote control applications where battery life is critical. The QE8 provides up to 14 years of functional battery for these systems. The software implementation is done using a layered structure to enable a very easy migration to other Freescale SO8 MCUs and facilitate the software maintenance. The block diagram shows the software components of each layer. This implementation is made using a 4-layer software architecture: hardware abstraction layer, hardware independent layer, services, and application. The software components were developed using CodeWarrior version 6.2. The implemented file structure with one folder per layer and one file per component is shown as well in the screen. The software is implemented in C language. This slide shows the main loop and the respective flow diagram. After initializing the system, the software checks for a button press. If this happens, the system will check for a button hold condition. If this condition is true, the system will go to the sleep. If there is no button hold, a frame will be generated and the message will be sent. If there is a low voltage warning condition, an additional message will be transmitted. Another proposed transmitter version is based in the ultra-cost-effective KA1. This sub 50-cent microcontroller provides enough functionality to support a low-end solution. The compact implementation of the code uses only 894 bytes of flash and 33 bytes of RAM, and it's completely coded in C. There is a simplified layer structure in this software implementation. The model consists of individual blocks that are used by the application. The different software components are organized in individual files visible in the file structure. The software was developed using CodeWarrior version 6.2. The main flow diagram and its code are shown in this slide. There are basically 4 decisions: button press, valid button press, low voltage, and button hold. The most important actions performed are sending a message, go to sleep, wake up, and contrast control for hold and LED blinking features.
Since the receiver has just been programmed, there are no fobs currently learned. If any of the buttons of the key fob is pressed for the first time or after a memory erase, the message "Not valid RKey ID" will be displayed. IDs are saved in flash and are not erased by turning off the SO8 SH8 MCU.
The SH8 is highly integrated low-cost 8-bit microcontroller. The part is also used by the higher-end remote keyless entry BKSP from Freescale. The receiver features are listed in this slide. As the QA transmitter, this implementation is made using a 4-layer software architecture. The block diagram shows the components of each layer, and the file structure is the implementation in CodeWarrior. In this implementation, for each layer there is a folder that contains the 2 files of each component. This implementation is based in a scheduler that has 5 different time slices, each executing different functions at a different frequency. This project uses the smaller and the largest time slices. The smaller slice saves and identifies the different key fobs. It also displays messages throughout the serial interface. The largest slice handles the memory management and LED indication functions.
Press the switch 1 of the demo SO8 SH8 for 3 seconds. The message "Enter learning mode" should be displayed in the hyperterminal. Press any key fob button within the next 5 seconds and the message "ID saved" will be displayed. The ID is saved in flash and preserved until a memory erase is performed. If no button is pressed during learning mode time, this mode will be exited and the message "Exiting learning mode" will appear. If the maximum number of allowed key fobs is reached, the message "Memory full" will appear and the learning mode will be exited. To avoid saving 2 times the same ID and waste flash memory, when trying to save a previously saved key fob, the message "ID duplicated" will appear and the learning mode will be exited without saving the fob ID. When transmitting with a previously saved key fob, a different message will be shown for each individual button. For example, when pressing button 1, the message "Button 1 pressed" will be displayed. When pressing 2 or more buttons, these combinations are similar to pressing a different button, and the message "Other button combination" will appear.
The current consumption in low power stop and run modes for the different transmitter solution is shown in this slide. Low battery detection thresholds trigger the receptor to send an additional message indicating the condition. Battery duration estimations are provided. These are based on the typical use of a key fob, 12 daily button pressed with.
For a longer battery life, when no button is pressed, the key fob is in low consumption mode, consuming a minimum current of 0.27 microamps. When a valid button is pressed, the SO8 QE8 wakes up and the key fob transmits a message consuming 5.6 milliamps of current during the button press. To avoid wasting battery life due to accidental button presses, the software has a configurable hold time, and when a button exceeds this time, the key fob goes to standby mode, consuming less current. The messages of the press button stop showing in the hyperterminal. 3-4. Additionally to the possible low battery indication LED, the receiver is able to identify when the key fob is in a low voltage condition. When this happens, the message "Low voltage detected" will be displayed in the hyperterminal besides the message of the button pressed. Press the switch 2 of the demo board for 5 seconds. The message "Memory erased" will be displayed. All previously programmed key fob IDs will be erased. If after the memory erase any button is pressed, the message "Not valid RKey ID" will be displayed until saving the key fob ID.
Thank you for joining this Freescale video. We hope it has been helpful and that the Fixed Code Protocol implementation helps fulfill your design challenges. There are 4 documents with deeper information available at Freescale webpage. 1 user guide for each implementation, and a quick start guide that helps setting the system up and running. Stay tuned for the next Freescale video training.